This is the lesson for Algebra 2-3. What we're doing today is writing inequalities for given situations and graphing them on a number line. So Alan's camping troop is selling popcorn to earn money for an upcoming camping trip. Each camper starts with a credit of $25 towards his sales, and each box of popcorn sells for $3.75. Write a function, f of b. Now notice that it says f of b. That means we have to use f of b in our equation. So f of b equals, we write a function f of b to show Alan's total sales as a function of the number of boxes, that's where the b is coming from, of popcorn he sells. So each box is $3.75. So 375 times b. Again, notice that I'm using a b, not an x, because that's what it says to use. That's what's inside the parentheses. Plus, he has a credit of $25. So plus 25. Analyze the function you wrote. Identify the independent and dependent. Remember, back from chapter 1, the dependent depends on the independent. The dependent depends on the independent. So the independent here would be the boxes of popcorn, and the dependent would be your total sales. Because the more you sell, the more money you make. So the thing that is changing all the time is your total sales based on the number of boxes. What is the rate of change, and what does that represent in this problem situation? Your rate of change is the number that is in front of, normally it's your x, this time it happens to be a b. So your rate of change is the 375. That represents the price of a box of popcorn. What is the y-intercept, and what does that represent in the problem situation? The y-intercept is always your plus or minus whatever. So that is the 25, and that is the credit that you're starting off with. So if we want to graph that equation, if we want to graph 3.75b or 3.75x plus 25, the graph of it would look like this. So what you're going to have to do is you're going to have to identify different areas on the graph and tell what they represent. So what does the circled area represent? Well, notice that we're going over in boxes of popcorn. This is at 420. How do I know it's at 420? It is halfway in between 360 and 480. Each box here is represented by 60. So this is 420. I go up to 420, over to 1600. Notice that they tell you what the point is right here. All right. So that's that point. What does this circled area represent? Well, that circled area represents the sales if they sold more than 420 boxes. All of the sales that were less than 420 are right here. These are all the sales that are less than 420. So if they only sold 120 boxes, it would be here. 240 boxes, it would be here. 360 boxes. This is where 420 is. So at that dot, all right, it's an open dot. The circled area represents all the boxes, it represents all the profits above if they sell 420 boxes. So B is greater than 420. How would that graph on a number line? It'd be an open dot, arrow going over to the right. This is representing all the profits or all the total sales if they sold more than 420 boxes. What does the boxed area represent? Well, that's all the boxes that are 420 or less. All right, 420 or less. So this would be B is less than or equal to 420. So that represents 420 or less. Notice that it's a closed dot right here, all right, because it's the or equal to. This was an open dot because it's not the or equal to. An open dot, there is no equals bar underneath the inequality. A closed dot or closed circle, there is an equal bar under the inequality. So an open dot is being represented by less than or greater than. A closed dot has the or equal to. How I like to remember it is that if you have to do more work by putting the or equal to underneath, you have to do more work by filling in the dot. So these are what these represent. An open circle is also So more than, at least, no less than, at most, no more than, and exactly. All right. What I was going to say before was a closed circle also is represented by the equal to sign. A closed circle is also the or equal to sign. Because we're going to have a question like that. You need to know in the context of word problems what these words represent. So more than is just like greater than. So more than is greater than. At least, you have to be at least 16 years old to drive a car. You could be exactly 16, or you could be more than 16, because you can be older than 16 and drive a car, but you can't be less than 16. So at least is greater than or equal to. No less than. No less than means that it could be greater than, but it could also be equal to. Less than is less than. At most, that's the most something could be. It could be equal to that, or it could be less than that, but that's the most that it could be. So you could have less than or equal to. No more than. No more than. It could be less than, or it could be equal to. I'm going to add another one in here that you might see sometimes. Fewer than. Fewer than is just like less than. Exactly is sort of an oddball. Exactly is equal to. So looking at our graph here, we're looking at tickets sold opening night along the bottom and the total sales of those tickets. So these were obviously, there were like $400 of ticket sales before opening night. That's why it's starting here at our Y-Intercept. There's like $500 worth of tickets sold before opening night. And then these are the number of tickets sold opening night. So when will there be at least $800 in sales? So 800, I'm going to go over to 800. I'm going to go over till I meet my line. Notice that it's right there. I go down and it's at 30. So 30 is in our inequality statement. We're going to have an X. At least 30. At least 30 is greater than or equal to. All right. At least is greater than or equal to. So at least $800 is everything above 30. So it would be represented by all this on our graph. So at least $800 in sales. So that's the smallest that it could be is 800, and it's bigger than that. So if we were going to graph this on a number line, we'd use a closed dot here, arrow going to the right. Remember that our arrow points in the same direction as our inequality sign, as long as the letter comes first. When will there be at least $1,400 in ticket sales? So 1,400, I go over to 1,400, go to my line, which is right here, go straight down. I'm looking at 90, all right? I'm looking at this point right here. So I'm looking at 90. So I know I'm going to have a 90 in my inequality statement. When will there be less than $1,400 in ticket sales? So less than is the less than symbol. So when I go to graph it, I'm going to put an open dot, arrow going to the left. Again, the arrow points in the same direction as the inequality symbol. Where would I be looking at that point on the graph? I'd be looking at all this. When will the ticket sales be less than 1,400? So 80 tickets, 70 tickets, 60, and so on and so forth. When will there be exactly $900 in ticket sales? Exactly 900. So 900 would be halfway in between 1,000 and 800. And I'd go over to my line, go straight down. I'm looking at 40. So this would just be X equals 40. Exactly is just equal to. So all I would put is a dot. Exactly would not have arrows at all. Because we're not having less than or equal to, it's exactly or equal to 40. Use the graph to answer each question. So now we're looking at we're back to the popcorn question, all right? How many boxes would Alan have to sell to earn at least $925? So go to 925, go over to your graph. I'm gonna say that it's at 240 here. So earn at least $925. So 925 is going to be at 240. So I have my X and I have my 240. At least is going to be greater than or equal to 240. So I'm looking at all of this part of the graph because that's all above the 240 and 925. How many boxes would Alan have to sell to earn less than $2,050? So 2,050 is right here. Go over to my graph, go straight down. All right. Remember, these were counting by 60s because this was 420. So this would be 540 right here. So I'm going to have 540 in my inequality statement. I'm going to have my X earn less than that, so less than. We'd be talking about this part of the graph. How many boxes would Alan have to sell to earn exactly 700? Exactly 700. I would go from 700, go over to my graph, go straight down. I'm going to say that it's at, remember, each of these boxes were 60, so this is at 180 right here. So it's X equals 180. So on your homework today, you're going to have questions that sort of look like this. I don't really like how they give an example of this, and you'll see why. Leon plays on a varsity basketball team. So far this season, he's scored a total of 52 points. He scores an average of 13 points per game. The function f of x equals 13x plus 52 represents the total number of points Leon will score this season. Write and solve an inequality to answer each question. How many more games must Leon play to score at least, remember, at least is greater than or equal to 117 points. Now, they sort of write their inequality statement backwards. I don't like how this is written right here, all right? I think it makes more sense to put the f of x equals on the other side, the f of x being the 117, all right? So I would actually write this inequality statement like this: 13x plus 52 is greater than or equal to 117. Notice that they have everything written backwards, so their inequality symbol for at least is backwards. I don't like how that's written at all. All right, so if we would solve this, we would do minus 52, and then divide by 13, just like they did here. And we would end up with x is greater than or equal to 5. Notice, again, they put their answer backwards. 5 is less than or equal to x. That is the same answer. It's just flipped around backwards. I don't like how that looks at all. I would prefer if you wrote it this way. One more question. The slope or rate of change in this graph. Now, when you take a look at a graph, you always read the graph going from left to right, just like you read a sentence. So as we go from left to right, we're going down this graph. So the slope is negative because we are going down as we go left to right. In the popcorn question, for example, our slope was positive because we are going up as we go from left to right. So going up is positive, going down is negative. When will the hikers be at an elevation of at most 3,000 feet? So 3,000 feet would be the most that they're at. Here's 3,000. I would go here. Now, negative sort of work backwards, all right? When will the hikers be at an elevation of at most? That's the most that they could be at is 3,000 feet. Well, that would be represented by this part of the graph, all right? That's where they're at most. So it's when time is greater than 90, all right? Here's 90 on our graph. We're talking about all this part of the graph. So we would have the inequality statement. You could use t for time if you wanted to. I'm going to use x is greater than or equal to 90 because that's when they're at 3,000. We're talking about this part of the graph. So this would be a closed dot, and we'd go to the right because we're talking about this part of the graph. It's sort of backwards of what you would think it would be because 3,000, that's the most that they could be. When will the hikers be more than 1,800 feet? If we take a look at 1,800 feet, 1,800 would be right in here approximately. So I'm going straight across to here. That is 150 because we're counting by 30s on this graph. So that would be 150. So when will the hikers be more than 1,800 feet? More than 1,800 would be all of this area because we're talking about the elevation. So that would be that area of the graph. So when we're looking at the time or our x, we could use t or x. We're at 150, and we want all the time because remember they're coming down the mountain. All right, they're coming down. So we're looking at all this time, so it would be less than 150. So that's going to be an open dot, arrow going to the left. So just be careful. You always want to use an open dot for less than or greater than. You want to use a closed dot for the or equal to's. Anytime that you got to draw that or equal to, you need to do more work by filling in the dot. Make sure that you realize that at least is greater than or equal to. That's probably one of the ones that we use the most often. We also use at most. That's the most that it could be. At least you have to be at least 16 years old to drive a car.